Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4 because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7/4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this because we can divide top and bottom by 4. So that would be 23/7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2/7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides, and so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometres and I want to convert it into metres, then we know we just times it by 1,000. So 2 kilometres is 2,000 metres. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually times it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's a million. So we times it by a million. So 13 kilometers squared is going to be the 13, and then it's going to be times by a million. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in 2s, so this will be 28. So the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. Now the rules of indices say that when you've got two numbers of the same base, and you divide them, and the base is the big number here, the 11s, right? And you divide them, you take away the powers. So we're going to do 11 to the power of 21, take away 14. Which is going to be 11 to the power of 7. So our answer is 11 to the power of 7. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. To find the median, we need to have all the numbers in a list from smallest to biggest and find the middle num. Now, we can't do that when we're using a table like this, or it's not very practical to. So we need a kind of different strategy, and the way we do it is to use a simple formula to find the position of the median. Now, the median will always be in the n plus 1 divided by 2 position. So we need to find out what n is, and we do that by adding up all the frequencies there. So let's add those together and you get the sum of f. So those add up to 15. So if you do 3 plus 4 plus 2 plus 1 plus 5, you get 15. And so we've got 15 plus 1 divided by 2. 15 plus 1 is 16, divided by 2 is 8. So the position of the median is in the 8th position. Now, to easily find out which group, because it's asking for the class interval, which is just a fancy way of saying a group. So it could be this one, or it could be this one. To easily find out which group the median is in, what we do is a quick running total. So what I'm going to do is add up the frequencies as I go along. So we've got 3 there. 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, plus 5 is 15. And then what I do is just convert those into 3rd, 7th, 9th, 10th, and 15th. So what those numbers are the last time that a number is in that group. So we've got 3 numbers that are in the group 10 to 25, and the third one is the last number in that group. The fourth one, therefore, will be in the 25 to 40 group. So we're looking for the 8th one. Well, the 7th one is the last one in this group. So the 8th one will be in this group here, as well as the 9th. Then the 10th one will be in the next group. So when it asks for a class interval, all we need to do is copy down exactly what the group is. So it's 40 to 55. And don't ever write down 40 to 55 or anything like that. Always copy it exactly from the table. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120, and we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line. And then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. To rearrange this, I'm just going to write out the equation again, and I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. Going to do a multiplication grid. And we're going to start by putting the x plus 12 at the top. So x, and then we've got 12. And the x plus 5 down the bottom, or down the side. So we're going to times these together. So x times x is x squared. X times 12 is positive 12x. X times 5 is positive 5x. And 5 times 12 is obviously positive 60. Put the terms together, and we notice that we've got two x terms there that we can add together. So we've got the 12x there and the 5x there. So when we add those together, we get 17x. And that's our answer. So our answer is x squared plus 17x plus 60. So we're asked to solve this, and so what I'm going to do is just write it out a bit bigger and get my solving lines in. And we can see the first thing we're going to do is divide by 20 both sides to get x squared on its own. So I'll leave x squared on the left hand side and 16 on the right hand side. Then we're going to square root both sides, and yes, that will give us x equals 4, but it will also give us x equals minus 4, because minus 4 times minus 4 is also equal to 16. So our two solutions are 4 and minus 4. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions. So 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13. So it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number. So it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the two graphs cross. So this here will be our solution. So x is 2 and y is minus 4. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. In this question we have a right angle triangle and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So A is 5, so it'd be 5 squared plus 12 squared equals C squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's C squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals C. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know C is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15. And therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15. And so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start, and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome would be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can divide top and bottom by 3. And that would be 16/75. So either 48/225 or 16/75. When it's said that y is inversely proportional to x, it means that y changes as 1/x changes. And to write this in an equation, all we do is we just write y equals k/x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So we're asked to solve f of x equals 23, but it tells us that f of x is 10x plus 3. So all we're really doing is 10x plus 3 equals 23. And we're just doing a simple solve. So get our lines in, and we're going to take away the 3 both sides, which will give us 10x equals 20. Then we're going to divide the 10 both sides, and that just gives us x equals 2. So our answer is 2. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is minus 1. So our answer is 10 minus 1. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times the top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. So if the area of the rectangle is 10 and one of the lengths is root 75, to find the other length we do the area divided by the length given, and that will work out what the other length is. Root 75 though is something that can be simplified, so let's simplify that. And it's root 25 root 3, so it's 5 root 3. So this equals 10 over 5 root 3. Now notice top and bottom can be simplified, so that becomes 2 over root 3. And we're asked to rationalise the denominator, so we're going to times this by root 3 over root 3. And so we end up with 2 root 3 over 3. So our answer is 2 root 3 over 3. Okay, so the first thing we're going to do is multiply the coefficient of the x squared and the number at the end. So 2 times 12, which is 24. And 24 is our target number. And what I mean by that is that we're looking for two numbers that multiply together to make 24. But we're also looking for two numbers that add together to make the coefficient of the x, which is 11. And that's our objective now. So looking at that, they add together to make a positive and they multiply together to make a positive. So we know that they are both going to be positive numbers. And so something we can do, if we're not quite sure what the numbers are, is just write out the factors of 24. And we've just got to focus on the positive ones. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. If I do any more, it will just repeat themselves. And then what I'm going to do is just add them together to find out which one gives us 11. And we can see here that the 3 plus the 8 will give us the 11. So we know they're going to be 3 and 8. Okay. So the next thing I'm going to do is just rewrite the question. But instead of 11x, I'm going to split that 11x up into the plus 3x plus 8x. I've just split it up into 3x and 8x, which actually equals 11, so I haven't changed the question at all. Now we're going to be looking at the two sections of our expression separately, and we're going to factorise them linearly. So I'm going to just put a single bracket here, 2x squared plus 3x, well it's only an x, I can divide out of both of them, which will leave a 2x plus 3 on the inside here. Looking at the next one, 8x plus 12x. Well, actually I can divide out 4 from both of them, so it would be plus 4 brackets, and it would be 2x plus 3. Now notice something, that the bracket here and the bracket here are equal. If they're not equal, you've made a mistake somewhere. So we can write that down, 2x plus 3. And then for the first bracket, it's just the bits on the outside, you put them together, so x plus 4. So our answer is x plus 4 in the first bracket and 2x plus 3 in the second bracket. And actually the brackets could be the other way around, so you might choose to put the 2x plus 3 first, then the x plus 4. So there are three parts to this power. We've got this negative here, which means to find the reciprocal of the fraction or flip it. We've got this 2 here, which is the root that we're going to find. And then we've got this 3 here, which is just a normal power. So a lot going on. So we're going to focus just on that flipping first. And so we're just going to flip the fraction, find the reciprocal of it. So it's going to be 100 over 9. And that gets rid of that negative, so it's just going to be 3 over 2 now. Now that root, it means we're going to square root the top and bottom of the fraction. Because it's a 2, it's a square root. If it was a 3, it would be a cube root. So we're going to square root the 100 to make 10, square root the 9 to make 3. We've still got that 3 on the outside, the power of 3. And that means we're just going to find we're going to cube the top and bottom of the fraction. So cubing 10 gives us 1000. And cubing 3 times 3 is 9, times 3 is 27. So our answer is 1000 over 27. So we're going to first of all factorise the quadratic, and we'll end up with 2 brackets equals 0. And to do that, what we want to do is multiply the coefficient of the x squared and the number and so on together. So we're going to do 12 times the 6, which is 72. So we need 2 numbers that times together to make that 72. And we're also going to look at the coefficient of the x, minus 17. So we need 2 numbers that add together to make that minus 17. They need to be the same 2 numbers. So what we can do is we can write out the factors of 72 and try and find them. We can kind of use our head. So it's going to be minus 8 and minus 9. I knew they both need to be negative because they add together to make a positive. Sorry, they add together to make a negative and they multiply together to make a positive. And then just trial and error, just think it through and get minus 8 and minus 9. So we're going to rewrite the expression on the left, but instead of minus 17 we're going to write minus 9x minus 8x, or whichever way around. So we're going to do 12x squared minus 9x minus 8x. I could have done it the other way around, plus 6. We're going to factorise linearly the first 2 terms, and we're going to factorise linearly the second 2 terms. So here we can actually divide out 3x from both of them. And we always put the minus on the outside, so it would be minus 2, and that would be 4x minus 3. The repeating bracket is our second bracket, so 4x minus 3, and then the bit on the outside, 3x minus 2, becomes our first bracket, like so. So let's put that back into our equation. And to solve this now, you get both of the brackets equal to 0. So we're going to get this equal to 0. And get our solving lines in. So we're going to add 2 to both sides. Oh, right, 3 there. Add 2 to both sides. And so we've got 3x equals 2. Then we're going to divide by 3 both sides. And we get x equals, and you can write this any way you want, but I'd write this as a fraction to keep the accuracy up. So our first solution is 2/3. And we're going to do exactly the same thing to the right hand side. Get it equal to 0. Get our solving lines in. And we're going to add 3 to both sides. So we get 4x equals 3. And again, divide by 4 both sides. And we get x equals 3 over 4. So our second solution is 3/4. We're going to first of all get x equal to the 0.151, blah blah blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000. And we'll get 151.151.151, blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151.151, etc. Take away 0.151.151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay, and then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'd be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here, but we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. So we're going to start by completing the square, which it's asked us to do. And so to complete the square, what we do is we put a set of brackets down, and we put x minus half of the coefficient of the x, so minus 5, and square it. And if you were to expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, so we need to remove that 25. And then we've got the minus 11 there, just that was on the end there. When you tidy that up, you get minus 36. Okay, now I'm going to draw the graph of y equals x squared. Oh, I'm going to sketch it. It will look something like that. Probably a bit of a curvier bottom on that. Let's try again. So it's going to curve at the bottom and go up like that. Okay, and the bottom of it, this part here, is at the coordinate 0, 0. Okay. Now, we remember, hopefully, from graphic transformations, is if you have got a minus 5 on the inside of a function, and if we imagine that this is our f of x, then this would be our f of brackets x minus 5, because it's got the minus 5 there. We move the graph to the right 5. Remember, it goes the opposite way. So if it's a minus 5, it goes to the right. If it's a plus 5, it would go to the left. We also know that if you have a minus 36 on the outside, which we do here, it moves it down 36. So it's going to go down 36. So our new minimum point won't be at 0, 0. It will move to the right 5. So the x coordinate will be 5. And it will be moved down 36. So it will be minus 36. It's always important with these questions to realise what the normal graph will look like before we have a look at what the new function will look like. So it's always good to remind yourself what a y equals sine x graph looks like, and it fluctuates between 1 and minus 1. If I write minus 1, and it goes up first of all at 90, goes back down at 180, down to minus 1 at 270, and then back up at 360. So it's just a simple sketch to help us figure out what's going on with the transformed one. So first thing I notice is there is a negative here, which just means it will be flipped in the x-axis. So this would become like this. And there's also a 2 there, so we're multiplying all the y coordinates by 2. So instead of this going down to minus 1, it will start by going down to minus 2, and it will go up all the way to 2. So we've got a nice idea of how this will look. And so we're going to just start plotting this now, I think. So it will go down at 90, which is, so there, to minus 2, back up to 180 at 0, and then back up to 2 at 270, down to 360, and then it will just go again, 540, up there, and then back down. Not the best graph I've ever drawn, but I think the examiner will understand that I know what the graph will look like, so don't panic about making too many mistakes when you're drawing curves. Just try your best to get it as low as possible, but don't go back and start feathering the lines or anything. I'm going to start off this question by factorising the denominator of the first fraction. And so we've got 1 over... I'm going to factorise it. Now, if you want to see how to factorise it, you can see other videos we've got. I'm kind of assuming you know how to factorise this if you're watching this video. And just keep the second fraction the same. Now, you can't add fractions unless you have the same denominator. So if you look at the first denominator, the only difference between the first and the second is that 8x plus 3. So I'm going to times top and bottom of the second fraction by 8x plus 3. Now it helps us to remember that technically that bottom expression, the x plus 2, is in brackets. So I'm going to just copy down the same first fraction, because we're not really doing anything with that. And what I'm going to do is just times top and bottom by the 8x plus 3. 1 times 8x plus 3 is just 8x plus 3. And that should do it neatly. And we've got the 8x plus 3 times the bottom, which will just give us the same denominator. So now the denominators are the same, we can just add the numerators. So it's just going to be 1 plus 8x plus 3, or in other words, it's going to be 8x plus 4. So it's 8x plus 4. And the bottom one is going to be 8x plus 3 and x plus 2. To find the inverse, we're going to first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here, so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. And that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. So there are many ways to solve a quadratic, but in this question we're specifically told to complete the square. So I'm going to start by just copying down the question. And when we're completing the square, we're interested in the x squared and the x term. And we start by just writing down a bracket with x, and then we're going to add or subtract the coefficient of the x term, half of it anyway. So the coefficient of the x term is minus 12, so half of that is minus 6. Close the bracket and write squared. Over here we're just going to see what that gives us. So it'd be x minus 6, x minus 6, and that would be x squared minus 12x plus 36. So this creates a plus 36 we need to get rid of. So we're going to take away 36. Then we've got the minus 20 from the question, and then it's an equation, so we get it equal to 0. And then finally we've got x minus 6 squared. Add the minus 36 and the minus 20 together, and you get minus 56 equals 0. Now we solve it, so we get our lines in, and let's solve this. So I'm going to use all the same colour maybe in the equation now. So we've got minus 56, so we're going to add 56 both sides. Get the right function, so plus 56 both sides. And that will give us, that will leave the x minus 6 squared on the left hand side equals 56. I'm going to square root both sides to get rid of the squared. So x minus 6 equals, and then square root of 56, we just leave as root 56. And then we're going to add the 6 to get x equals. And that will give us x equals, and then we've got a 6. Now, when you square root 56, you can get a plus or a minus. So it'd be plus minus square root of 56. So my answer would be 6 plus minus square root of 56. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.